Our question asks, what are the principal values for theta rounded to the nearest tenth of a degree such that sine theta equals negative 0.3121? Well, we're looking for angles between 0 degrees and 360 degrees inclusive. So we're going to use a unit circle or winding function analysis, and we're going to think of sine theta as the y-coordinate of the point on the circumference of the unit circle that the terminal arm of the angle intersects. Okay, so what does that mean for purposes of this question? What we do is we draw ourselves a unit circle, and since sine theta represents the y-coordinate, I'm going to draw a line where y equals negative 0.3121. Well, y equals negative 1 here and y equals 0 here, so y equals negative 0.3121 right about here. Okay? So our angles are going to be represented here and here. I hope you can see that. And our first angle is going to be this one, and our second angle is going to be this one. Pretty nifty. So what we do is we'd like to know obviously the magnitude of those angles, so we use our calculator for this next part. What is the sine inverse of negative 0.3121? Well, it's approximately equal to negative 18.2 degrees. Let's use a little common sense here, which is, an uncommon thing to do sometimes. Negative 18.2 degrees represents this angle. Well, that means that the magnitude of this angle, where you see my pen, is 18.2 degrees. Well, since these circles are symmetrical and the right side of the circle is a reflection of the left side of the circle, we can also say that, the right side of the circle with respect to the y-axis is a reflection of the left side with respect to the y-axis. Therefore, the magnitude of this angle is equal to the magnitude of this angle. Okay? Which means that the magnitude of this angle here is 18.2 degrees. Well, we know that this represents 180 degrees, and since we're going to add 18.2 degrees here, our first angle is going to be 180 degrees plus 18.2 degrees, which is 198.2 degrees. Now our second angle is represented by almost a full 360 degrees, but we seem to just stop short by about 18.2 degrees here. So the magnitude of that angle will be 360 degrees minus 18.2 degrees, which is 341.8 degrees. So our two principal angles, each of which meet the condition that sine theta is negative 0.3121, are 198.2 degrees and 341.8 degrees. Okay, let's try another question. This time we'll do a question involving cos theta. What are the principal values for theta rounded to the nearest tenth of a degree such that cos theta equals 0.4107? Well, we know that cos theta represents the x-coordinate on the circumference of the unit circle. So we draw the line x equals 0.4107. That's a vertical line right about here. And we see that one of our angles is here and one of our angles is here. So we're going to look for this angle and this angle. So naturally we find the cos inverse of 0.4107, which is approximately 65.8 degrees. So that's going to represent our first angle, 65.8 degrees. Theta 1 is 0 degrees plus 65.8, which is 65.8. And our second angle is going to be almost a full 360 degrees again, but we're going to stop 65.8 degrees shy of that. So our second angle is 360 degrees minus 65.8 degrees, which is 294.2 degrees. All of these answers obviously are approximate. And so our principal values for theta are approximately equal to 65.8 degrees and 294.2 degrees. Our last question asks, what are the principal values for theta rounded to the nearest tenth of a degree, such that tan theta equals negative 0.2151? Well, tan theta, as we know from grade 10, is equal to y over x. In this circumstance of a unit circle centered at the origin. So that's much like saying the slope of the relevant line is negative 0.2151 and it cuts through the origin. So we draw a unit circle and a line with a slope of negative 0.2151, which is, you know, a moderate, very moderate negative slope. And that should look like a straight line, and it should go through the origin. My artistic skills lack something. So we're going to look for these two angles. What is that one? And what is that one? Well, we can tell if this was, obviously, if this looked more like a straight line, we'd be able to see that this angle, the magnitude, is clearly equal to this angle in terms of the magnitude. So we use our calculators and we ask ourselves, what is the tan inverse of negative 0.2151? We see that it's approximately equal to negative 12.1 degrees. So theta 1 is going to be 180 degrees minus 12.1 degrees, because negative 12.1 degrees represents this angle here, which means the magnitude of this angle here is also 12.1 degrees. So our first angle is 180 minus 12.1, which is 167.9. And our second angle will be almost a full 360 degrees, but we will stop short by about 12.1 degrees. So the magnitude of our second angle, 360 degrees minus 12.1 degrees, is approximately equal to 347.9. Meaning the principal values of theta are approximately 167.9 degrees and 347.9 degrees.